Okay, we'll go ahead and get started. Thanks for joining us. My name is Dan McGhan. This is Wirth, and we're going to talk about real-time data in web applications with Graal.js. Just have to show the safe harbor statement. Please don't make any purchasing decisions based on what you see here today. All right, so here's a brief overview of the agenda. We'll start by talking about how we got here, and then talk a little bit about kind of where we're at now, and then finally talk about the database. And so usually what I would like to do at this time is a really fun demo. I got to get you guys involved. Unfortunately, due to a networking issue I couldn't quite figure out in time, no demo, no live demo. But there is video-based evidence that it in fact works. And this is one of the recordings from Open World earlier this year. And this is the app that I end up showing. And what I ask folks to do in the audience, it's just a listing of cities. Some website ranked 20 cities as the most livable cities to go live in. And I ask folks to vote for their favorite city, and you'll see on the left here this kind of number going up as votes start streaming in. And then there's this other number over here, and I ask folks to watch that number as well. And what you see over time is that the number on the left comes up a lot higher. That's one, increment per vote, essentially. And the number on the right is going to increment much slower. And I just ask folks to remember that, and I kind of explain that later on in the talk. And then I cheat, and then I vote for my favorite city 1,000 times using a command line tool so no one else wins. That's the demo, anyway. All right, so let's talk a little bit about how we got here. It's 2007. It was exactly 20 years ago that we got HTTP. HTTP became a thing. And it was a simple request-response protocol, right? So the web browser would issue an HTTP request to the web server. Web server would read some static file, usually it was Apache or something like that, and it would send the static file back to the web browser, and the web browser would render it. That was cool, it worked, but we got better. We realized we could involve a database in the mix and make things more dynamic. So the web browser would still issue that same HTTP request to the web server. The web server would then use some kind of database driver technology and start issuing queries against the database, get the responses back, generate a dynamic web page, and then send that back out to the browser. Cool. Now, some of you are probably thinking, actually, Dan, we do some complicated work. We have to use transactions, so our traffic looks a bit more like this. And you know what? We're a global company, so we got to shard our databases so it looks a bit more like this. And you know what? Based on CPU and memory utilization, we're going to scale our web servers automatically, and we're doing all that because we got a whole lot of users. And so really, our traffic ends up looking a bit more like this. I get it. This is the reality a lot of folks are dealing with today. For this demo, we'll keep it simple. But just know that the concepts that I'll be talking about today can be scaled up to this level with a bit more code. That's all it takes, is a bit more code. All right, so at this point, you could almost say that the browser is like a cache of what's in the database, right? They're essentially the same in terms of the data that the user is viewing. But then we all know what happens. Somebody goes in, makes a change in the database, and all of a sudden, the cache in the browser is stale. So that's the problem. Well, we've had the ability for the longest time to communicate from the database to the web server to let the web server know that there's been a change to the data. What we've not been able to do is go from the web server to the browser and let the browser know that that cache is stale at this point. That was impossible, and it was for good reasons related to security. Thus began the quest to simulate this kind of thing. Now, raise your hand if you're guilty of any of these. And I, in fact, am guilty of all of them. Yeah, fun stuff, right? It all started with the Forever frame. This one actually goes back all the way to IE6. You can still do that one in the latest browser. Oh, the oldest browser, rather. And what you would do is you would have your main web page, and inside that you would hide an iframe. And you'd use the iframe to go out and get new data. And if it got new data, you'd proxy it up to the parent page and just inject it in. Cool. Things got a lot better when we got Ajax, and we started using Ajax polling. And we all give Microsoft and IE a real hard time, but frankly, it was Microsoft that invented Ajax. So hats off to them. And Ajax polling was just this thing where you'd use something like maybe set interval, and you'd occasionally go back to the web server, and you'd say, hey, is there any new data? Any new data? Any new data? And the problem there is twofold. One, it's a complete round trip each time. And two, you're asking the web server a lot of questions when there are no changes. And if it has to then ask the database. That's a lot of work for no reason. It just doesn't scale very well. Things got better with long polling, because with long polling, you would essentially establish that connection to the web server, asking it, hey, you got new data? And then you would just wait. And when the web server did get new data, it would send it down to you. So number one, you're not asking unnecessary questions, and two, you're cutting down that response time some. So that was really good, and that's actually the technique that Google was pioneering with Gmail. Things got even better with HTML5 server-sent events, but most folks don't even know what they are. And there's a reason for that. And the reason is we got some better technologies, and that brings us to where we're at today. So some new technologies have emerged. We have WebSocket now, and we have WebRTC. WebSocket is what I ended up using in the demo, but I'll talk about WebRTC first, because WebRTC, it's like real-time communication. You think, obviously, that's the technology I'd have used for a real-time demo. But no, WebRTC is all about getting peer-to-peer connections going. It's a little complex in that it requires a turn server to get the initial peer-to-peer connection established. And you can host your own turn server. It's not terribly hard, but most folks are going to go ahead and use a paid service to do that. But it's a really great technology for streaming audio and video, but also communicating arbitrary data. And just think video games. If you have two peers connected directly, they're avoiding round trips to and from some middleman. So really great for video game technology. But what I wanted to do was just simple. It was just from the server to the client. In that case, WebSocket is a much better choice. So WebSocket is all about just enabling that bidirectional communication we never had the ability to do before. It works with HTTP, preferably HTTPS, as like an overline protocol, and then it upgrades to WebSocket. So it's really nice, nothing new going on there. Perfect for what I need to do, which is just push data out. Now, if you're choosing between these technologies, keep in mind that WebRTC is still not supported on some of the older browsers. If you have to work with IE11, it's not going to work. I've been watching this global support number over here increment slowly over time, so in the future this might be a good option. WebSocket, on the other hand, is already at 94% globally. Once you're above 90%, it's pretty safe to use anywhere unless you're working in an enterprise where you have to support an older browser. So WebSocket definitely ready to go in that regard. Here's what WebSocket looks like if you start to use it. So we have here on line 2, we're declaring a variable called socket, and we're setting it equal to a new WebSocket instance. We just point it to the WebSocket server. Once we have a socket instance, we can add event listeners, and there's two events that matter. We have open and message. So open means we're connected, and once we're connected, we can use the socket and the send method to send data down to the server. Or conversely, when the message event happens, that means the server is trying to talk to the client. We'll get the event object, and of course on that there'll be some data, and we can work with that in the client. Now that I've explained the WebSocket API to you, I would like you to promptly forget it. And the reason is because, like a lot of good APIs, it's a really low-level API, but it's not very practical for getting work done. Instead, you want to use a higher-level API on top of that one. So there's a let's say, an open source project called Socket.io that you can leverage. Socket.io comes in two parts. You're going to have a client-side part, and you're going to have a server-side part. And what it is, it's essentially its own protocol. And this is nice because long polling actually works even in the older browsers. It starts with long polling. And if it finds that both the client and the server support WebSocket, then it goes ahead and upgrades the connection. So it's great for backward compatibility. Has a really simple API, all kinds of great support, things like multiplexing and rooms. So if you're working like with chat servers or that kind of thing, it's already built in. But auto reconnect is also a real big deal. Like if you imagine, somebody's connected and then they go in the subway or the metro and they come back out and they open up their phone again, the browser is no longer going to have that WebSocket connection, right? Well, Socket.io will automatically just start pinging the server, trying to reestablish that connection, getting the latest, greatest data, so you don't have to worry about that kind of stuff. It's done for you. Now, my approach to solving this problem is to do something a little strange. So most folks, when they think about building a REST API, they're thinking about a public API, an API they're going to expose to the public internet. But to get this working, what I went ahead and did is wrote both a public API as well as a database API. And you can put the public API behind a firewall, just making sure that the browser is only able to talk to that public API, and your database API is safe and secure behind the firewall. But the idea is that you need a means for the database to be able to communicate when that changes happen, and then of course you'll end up pushing that out through the web server. So let me do a code review. I'll show you first, we'll do this in two parts. I'll show you first some of the code related to the front end and what I did there for the demo, and then we'll look at the back end a little bit later. So this project is essentially in two parts, client and server. And we'll start with the client. And this is essentially an Oracle Jet-based application. I won't get into details of that, but if you're familiar maybe with Angular, React, Jet is just Oracle's alternative to those solutions. And inside the source is where the main code is, and the JS is the main app. So one thing I needed to do was bring in Socket.io, and I mentioned already that it's two parts. So what I had to do in this client part was bring in the front end part of Socket.io. And the way I end up exposing that in the project kind of looks like this. So this is using require.js, so I need to require in Socket.io, and then an application configuration. In Socket.io, all I need to do is invoke it to get a single instance of Socket.io, and it just goes ahead then and connects to the web server. And the reason I kind of wrapped it in this module here is so that I could share it then, the state and such, with the rest of the application. You only really need one connection back to the server, so it's good to just centralize this and be done with it. So the next thing that matters is, let's look at the main page where folks do the voting is here. And what they see is a listing of cities, and they're just clicking the vote button, voting for cities. And what happens when they do that, they're interfacing with this template here. It's based on knockout templating. And so they're seeing a list of data that comes in from the view model, which is exposed here. And then there's just a bunch of methods and things that, when they click a button, it invokes the upvote function, which is defined in the view model. So if I open up that view model, what you'll see here is that I end up requiring in that module I showed you a moment ago, the single Socket.io connection, and I bring that in as I.O. And what I end up doing at first, when the first page renders, we fetch the latest and greatest data, but down below, I use on an event, and the event here looks like its name, so it's just a string. So I'm saying IO on cities.change, and we know we're going to get some data. I just take the data and push it into that data source, and it goes ahead and updates the data source in memory, and of course then the view updates to reflect the current state of the view model. So that's kind of in a nutshell what happens in the client side. And in the server side, well, I'll show you that when we get to the database part. All right, so myself, I'm an Oracle database person. I don't know what database you work with, but no matter which it is, you're going to need two things to get this kind of thing to work. You'll need a means of events, detecting when data changes, and you'll need a means of communication when the changes occur. So when we talk about events in the database, oftentimes the first people think about are database triggers. We could have used triggers for this. So with Oracle, we have two different types of triggers, DML triggers, such as insert, update type triggers, as well as system triggers, when folks log in or maybe alter a table, that kind of stuff, all kinds of triggers within the database. The way we might have constructed that is with an insert trigger. And so this trigger is saying, all right, after an insert on the vote table, and then the implementation for notifying Node.js, I'll show you a little bit later, but this is the type of trigger that we might have used to notify Node.js when that change occurred. But this would have been really bad. Can anyone guess why this would have been bad? Network bound I/O, right? So when you think about databases, a lot of folks always, or I/O in general, you have level 1, level 2 cache, you have memory, and then you get to disk. And once we get to disk, people are thinking, disk is slow, right? Well, what's slower than disk? Network. And so if you add a row-level trigger that has to communicate across the wire, in addition to doing the normal insert it already has to do, that's going to be real bad. So instead, we move on and maybe look at scheduler. So Oracle has a really robust scheduling API. It's called Scheduler. And you're seeing an example here of how I can create a job. And this particular job is of type PL/SQL block. You can do all kinds of options there, but what we're doing here is an anonymous block, and I'm saying begin, do something awesome, and end. And we can set that to frequency daily, but really when I create a job, I don't actually have to set it up so that it's out, running all the time. I can create a job and then call it on demand. And what's unique about that when you do it, it basically spawns a background process to handle the job. And so you're doing it asynchronously, so you kind of avoid some of the issues that you might have with triggers. You're not like holding things up. So I could have combined these two technologies. And so here I have a procedure. Again, the implementation we're not looking at just yet, but this is the procedure that's going to notify Node.js, and it's called, aptly, notify Node.js. So now in the trigger, all I needed to do is declare it as a pragma autonomous transaction. It's a transaction within a transaction. And then call create job, and job action just notify Node.js. It's just pointing to that procedure up there. So now it's going to invoke that whenever the insert occurs. So this would have worked. Maybe not the best option, but it would technically have worked. Maybe that's going to be the best option in some databases. We have another technology within Oracle that I could have used called advanced queuing. And advanced queuing is a really cool framework for these kinds of queuing architectures. You could do point-to-point. It's super flexible. You can set it up as point-to-point. You can do pub/sub depending on your needs. But one of the neat features that the advanced queuing feature comes with is a notification thing. So essentially, when a new message is enqueued, you can have it automatically call something else to then dequeue the message rather than having to poll continuously to see if new messages have come in. For my purposes, what I was doing, this was overkill, honestly, so I didn't want to do that. And oftentimes, you may have an existing table. Some folks say, well, couldn't you do this in the middle tier and not in the database? And the truth is, sure, right? If you think about it, we could have a lot of the logic in the middle tier, and when an update to the database comes in the middle tier, and let's say we're using an ORM, we could tie into the ORM. When it updates the database, we know something's been successful here, then we could push out changes to everyone, right? That would normally work. But what about when you don't have control and all of your users aren't coming in through your middle tier, right? What if you're working with an ERP where you can't really touch it in that way? Sometimes you might need another means of handling this, and you just want to know when data changes, and you don't have that level of control. Well, I started to look into this and found a feature. I'd been working with Oracle Database for over 10 years and just kind of stumbled on this one by mistake, and it had been there the whole time. It's called Continuous Query Notification. And here's an overview of how it looks. So this is a PL/SQL example. There's a Java API. There's all kinds of APIs, but this is the PL/SQL API. So in the declaration section here, I have to use this type. It's continuous query notification registration info. And then I need to initialize that type, and I pass in some parameters here. So one is called callback. And that's interesting for me. I'm a JavaScript developer, and we work with callbacks a lot. But turns out callbacks have actually been an Oracle database for a very long time. And then we have this some other parameters. I'll talk about one of those later. But then we're starting this registration. And what I do is I say I need to open a cursor for, and I have to include this reference to this function here. But then I can just select various columns from a table. So I'm opening a cursor and immediately closing it. I'm not actually executing the query. That's enough to register this query with our registration info, and we're done. And at this point, what Oracle's going to start to do is look at the result set of that query, and if the result set changes on a commit, if the result set changes, then it's going to go ahead and invoke this function here, notify the server, and of course we can notify Node.js that a change has occurred. that's the route I ended up going. As far as communication goes, again, this is going to vary by database. And Oracle, we've had all kinds of communication packages for the longest time, for TCP, for HTTP, and also SMTP and mail, if you need those. What I ended up going with myself was Apex Web Service. And Apex is short for Application Express. This is just a rapid application development environment for Oracle, but to support that product, they add a lot of PL SQL packages, and one of those is actually really cool, Web Service, and the reason I like it, if you're doing any kind of REST communication, it's like the go-to package. It makes it super simple to do REST-based stuff with Oracle. So now we're getting to the implementation of notifying the server that a change has occurred. And the signature, I do have to include this notification descriptor because the notification service is going to invoke this procedure, and it basically passes along some information about the change that has occurred. Depending on the change, you might, for example, get a bunch of row IDs telling you that these have been changed. But there are some algorithms that determine whether or not that's unreasonable, right? If somebody updates 1 billion rows, you certainly don't want to get that many row IDs, so they won't do that. But all I need to do then is declare a response object, a CLOB, and just say, all right, Apex Web Service, make REST request, point this at my Node.js server, and then I get a response and disregard it entirely because at this point, I've done what I needed to do. I've simply told the Node server that a change has occurred. And at that point in time, once the middle tier is aware of a change, it can do whatever it needs to do. It can go back to the database, grab all the data, shove it out to the clients. It can do whatever it needs. So I'll show you what I ended up doing here. So we'll back out and go into the server side of things. And remember, this is a Node.js application. I'm familiar with Node. You might have noticed the stickers, like JavaScript is my thing. Frankly, I can't convince Christian that I should be able to run Node on a server, so he lets me use Graal.js. That's where we kind of met in the middle, and I'll talk a little bit about that in a second. But I ended up using a Node style app, and so you're seeing a traditional file system for that. As far as socket.io goes, what I end up doing in the database API is I'm setting up some different routes here, and I have a route for supercities. And this is the route that the database is going to come in on. It's going to let me know that there's been a change to this. Technically, supercities is the name of the table. It might have been votes or something like that. But when that happens, then the Node server just uses another endpoint to get the data for that API. And once it has the data, it can then use the socket.io instance on the server side now to emit that change that you saw we were listening for on the client side. It's really this simple. You're just listening for an event on one end, and you're emitting that event on the other end and sending along the data. That's all it takes for socket.io. So they made this dead simple. Oops. One thing I'll mention, a last thing. So the PL SQL example you saw, it works. And as I mentioned, Java APIs, I'm sure a lot of folks here are Java developers. But what I want to see added is support, kind of native support like you guys have in Java for JavaScript. And so the way that might look if we kind of ignore oops. Bear with me a moment. Oh no. Kind of ignore how the PL SQL API looked. We could add something like this, and this goes back to the safe harbor slide in the beginning. This may never come to fruition. It likely will. It may not look exactly like this. So what I could do when we start up the Node server is get a connection to the database using the database driver. And once I have that connection, I could call create subscription. And what you're seeing here are parameters that are very much like those in the PL SQL side, but I can explain them a little bit better here. The one that really matters, and if you think back to that demo where we have two different numbers, right? So one number is a representation of the total number of votes, and that's going to increment as more and more people are voting. And the other number I mentioned was much smaller. And there's a good reason for that. Imagine, if you will, that for every single vote that everybody here was doing, I was then kind of doing these round trips, right? Every vote comes in, we're inserting that into the table, and then the change notification occurs, and we're going back out and pushing these updates with every single vote. It simply wouldn't scale. And in JavaScript, I don't know if it's called the same thing in the Java world, we have a concept known as like a debounce, where there might be a number of events coming in sort of as a stream, and you're saying, no, don't respond to all those events, wait until a certain threshold of time has passed, or group them together in some way. And that's what actually Oracle supported already, which was really nice. So there was this grouping capability, and we can group by type, and there's a grouping value of 1. Unfortunately, the minimum I could go is 1 second. I'm trying to get them to lower that. Who knows if they will, but 1 second was fine. And it surely helped. Basically, I could take all of the changes, all of the inserts that occurred in the votes table, group them together as a single change, and then propagate that change out to all the clients at once from that point. So that definitely scaled a lot better. Now, in this case, in this particular API, if we do it this way, once you create a subscription, you'll get a subscription object, which you can then use to register queries, and of course then Oracle's going to start listening on the result sets of those queries to see if any changes occur. And when they do, notice here the callback. In the previous PL SQL example, the callback was a PL SQL stored procedure, but here it could be a JavaScript function. And so that JavaScript function would again get the change descriptor and then do whatever it needs to do, select data from a table, and again use socket.io emit to emit that data out. So this, I think, would be a much better API, especially for JavaScript developers, but you already have some great options already in Java. All right, so I mentioned a moment ago that Christian is not going to let me run this application on a normal Node server. We're going to settle with Graal.js. And it turns out there are some really good things about using Graal instead. And this is a normal problem we have in the JavaScript world. I love JavaScript, but I'll certainly be the first to admit some of its deficiencies. One of those happens to be numbers. So what I'm doing here, I'm showing you the contents of a file called JavaScript.js. And you see I'm declaring two variables, value 1 and value 2, and they're both numbers, and we're initializing them to a string 0.1 and 0.2. And of course, after that, they're numbers. And when I add the two of these together and log out the value, it's a rounding issue, right? Some of you might be familiar with this. It's certainly a problem in JavaScript, and there are some libraries, but not a lot of great ways to solve this problem just yet. Hopefully we get decimal, but until then, not really a thing. But because we're using Graal.js here, I can actually do something a little bit different. And so here's a different version of the file. And when you see what I'm doing here, I'm actually going into Java and grabbing out a type from math, big decimal. And once I have that, I can initialize my variables using big decimal in the same strings. But now I have the APIs, right? I can use value 1 and add value 2 and toString that in console log, and I get exactly what I'm looking for, which is 0.3. So really nice technology, and I want to have Christian maybe just talk a little bit more about Graal.js.
Okay, thanks, Dan. This is just one example, one we found to be useful to you and easily explainable, that you can access Java classes here and use them in your JavaScript code. Now, that's not something entirely new. Rhino can do that, Nason can do that. On Graal, we extended that idea to a much bigger set of programming languages. We can do that on basically any programming language. That's the idea of the Graal VM. Graal VM, in principle, is based on the Java Hotspot VM. It's a plain Java Hotspot VM starting from JDK 9. In JDK 9, there is a JVM compiler interface, JVM CI, which means using that interface, you can use another compiler. There are two compilers by default in Hotspot, and this allows you to add any other compiler. Some you might write yourself, or Graal is the main example right now. Graal itself is written in Java, which means basically it's a Java compiler. So it can use Java code and execute it on Hotspot. That's nothing new. That's like using the traditional compilers. But adding the Truffle framework allows us to write language interpreters. JavaScript is one example here. JavaScript is interpreted at runtime on a Java VM, on the Graal VM. Now, that sounds very slow. Interpreting JavaScript should be horribly slow. We all know when you write an interpreter, things are slower than what you can do. You want to be able to compile that to machine code, to native code. You want native performance. But that's exactly what Graal is doing. It's executing your JavaScript code first in an interpreter, but then it's compiling it down to native code, to machine code. And in the end, the JavaScript code that you execute is as fast as with any other native compiler. Take V8 or Mozilla SpiderMonkey or any other example. But we cannot only run JavaScript. We can run more programming languages. We provide Ruby, Python, R, LLVM, so C, C++, Fortran, and many more. And there are academic collaborators we work with that add more languages to that spectrum. But it already shows it's a broad range. It's not just JavaScript. The nice thing, and that's what Dan has shown, is you can interact between these languages. You can send data from JavaScript to Java. You can call a Java method from JavaScript. That's what we have done. We've called the constructor of the big decimal class. We provided some data, and then we called the add function of that method. We can also do the same between JavaScript and Ruby, for instance, JavaScript and R, R and Python, and so forth. You can do any combination of those languages. And this will be fast, because there is no language boundary in between. In the end, it's all interpreted based on Java. It's a Java application. So our Graal compiler, the Graal VM, can compile that to native performance. I've already shown that 2 years ago here at Devoxx. Just search for Devoxx Graal.js. We had a demo there where I showed some interaction between JavaScript, Ruby, and R. What the news here today is that Dan's application, all the server-side application, can be executed on Graal.js. So it's a Node.js application, just a normal Node.js application with all the modules that Dan is using, database connection, etc. Be it native modules or modules written in JavaScript, doesn't matter. Graal.js can run that. And that basically means you can run any Node.js application now on the JVM, interop from Node.js to Java, and interop from Node.js to, say, Python. You have an existing Java library in your company, you have an existing Python library in your company, use that from your Node.js application now. When working with Java, we have one big disadvantage. Java itself is a huge system, and even running a Hello World Java application takes some time. Depending on your machine's performance, it will take up to a second that even a Hello World is executed in Java, just because there is so much initialization necessary. We solved that problem by our own Substrate VM. Substrate VM is an ahead-of-time compiler, meaning it takes all the Java code it sees. So, for instance, our JavaScript engine and Graal itself, and ahead-of-time compiles that to native code. That means that we can run on Substrate VM our Node.js execution with actually a better startup than the original Node.js, because we remove all the overhead that Java itself comes with. There is one culprit right now. On Substrate VM, you cannot dynamically load Java code because it needs to be ahead of time compiled. So most Java code won't work on Substrate VM if it's not known at compile time, at ahead of time compile time. We will solve the problem by moving Java also here, so interpreting Java in itself on top of Truffle. But that's for the future. Right now you have to decide whether you want to run on Hotspot, on Graal.js, which will give you good performance and allow all the languages to be run there, or on Substrate.VM, where you can only run the top-level languages here, excluding Java. So what's the big deal about Graal.VM? It allows you this interoperability. I already talked about that. Compatibility. Node.js, how good are we? We can run everything that's in ECMAScript 2017. So the current spec, we can execute it. We're already working on the next standard, ECMAScript 2018. Not sure what will be in there, definitely, but we're already working on those features. And compatibility is always hard to measure. What we did is we downloaded all the NPM modules that are out there. I think it's 450,000, 500,000 already. We checked those that we can run using the Mocha test framework, which is basically 60,000. And of those, 96%, just to give you a number, they run without any problem whatsoever compared to V8. Even those that fail might just be setup issues. Sometimes we pass more tests than V8 or different tests than V8, being the original engine in Node.js. But in general, it will mean that if you have a Node.js application, and we tried that with Dan's application, chances are very high that it will work on your machine. With Graal.js, allowing you Java interoperability, for example. Now, performance. How good are we in performance? I don't have slides. Again, I had slides 2 years ago in the presentation, but we are basically on par with existing engines. Sometimes we're 20% faster, sometimes we're 20% slower. On Substrate.VM, we are also as good as other engines on startup. On JVM, we need more startup time. So it takes a bit longer for your Node.js application to reach peak performance, but especially for a Node.js application, it shouldn't really matter. It will run on your server for a long time anyway. And if it takes 10 seconds to warm up, that shouldn't matter so much. If anybody of you is using it or will be using it and you find something that's not performing very well, please give us some information about that. We are happy to look into any problems that you might find. Another very cool feature about Graal.js is tooling. Talking about different programming languages and combining them, what you also want to do is to debug them together. So you have a JavaScript application that calls into Ruby, that calls into Python, and that accesses some Java data structure. We can provide you with a debugger and further analysis, monitoring tools, etc. that are language agnostic, so they work across this boundary. You will see a stack frame in your JavaScript application that is inspecting a Ruby object that has some Java data in itself. That's ongoing work on our side, also some research involved there, but we can already connect to existing tools like the Chrome debugger, and you can, on Graal.js, you can debug, for instance, an R application in the Chrome debugger using that approach. If you want to try out what I just talked about, on the Oracle Tech Network, OTN, you can download a preview of that for Linux and macOS. And most of what I said is open source already, so on GitHub Graal.js, you can download that yourself, build it yourself. JavaScript is not open sourced at the moment, but chances are very good that it will be open sourced within the next months. We're still trying to get all the approvals for that, but we're looking to that. Ruby, Python, and R, and Graal itself, so the Java compiler, they are open source already. You can download them and build them yourself right now, or use the image where also JavaScript and the Node.js support is included. So much for our presentation. Thank you for being with us here, and if you have any questions to either parts, feel free to ask them now. Are there any questions?
What about C calls in Python, like sklearn Thank you, Dan. Are they supported?
So are C calls in Python supported? I can give you a two-part answer. Yes, they are supported just as they would be in normal Python. So for normal Python, you need these native libraries. We have the same problem in Node.js. Node.js to some degree is implemented in C. So we need to support that anyway. So that works, but then you still have a language boundary in between. You have C code, you have Python code. The other answer is you can execute the C part in interpreted mode on top of that stack, which will allow you to, for instance, debug it, analyze it, monitor it. Both is possible. Right now, I would suggest the direct call, because this is not perfect yet. It might work, it might not work, but it's possible in both ways. Yeah, please.
Could you say anything about any production systems that are running on Graal?
Thank you for that question. The next talk in room number 6, if I'm correct, is Twitter. They are using GraalVM in production. So Christian Tallinger, it's just the next talk in room number 6, if I'm correct. Please double check. Who is using that, for instance? And we are right now ramping up several Oracle internal projects that will use that. But Twitter is a, I think, very good example. They use the JVM a lot, and they use GraalVM now for some of their use cases. And Chris is happy to tell you more about that. Yeah.
What time do you estimate that 2018 features like await and async will arrive on Graal?
So await, what the question was, await async, when will they arrive in JavaScript?
Yeah, well, in the Graal,
Yeah.
The funny thing is, so what I learned when I started working with this technology is that they have a node binary. So you're literally calling node just like you would with the regular node, except that it's precompiled with Graal.js or Graal instead of V8, right? And when I did node-v to check the version, it was 6 point something. I can't remember what it was.
6.3.0, I think, or
6.3.0,
6.7.0
right?
at the
Now,
moment.
async await support was actually added to Node.js in 7.6. But my application had already been converted to async await, and it worked fine. So even though, it's because they inherited it from V8, even though I was running technically on an older version of Node, async await support was already there because of Graal.
So we are ECMAScript 2017 compatible, and I think async await was added 17 or 16, not sure about that, but it's already there. There will be new features in 2018, but basically it's there already. I think we have some troubles with destructuring the result of an async function that might not work on Graal.js at the moment. But
it's already there, that's great.
Yeah,
yeah,
it was very cool. Any other questions? All right. Thank you all very much.
thank you. No. Socket, I don't.
Socket
Can you
item
please
job.
come down
Yeah,
and
yeah.
we'll
We can chat.
answer it here.